All right, we're back. We're on page 9 of notes 10 of Calc AB, and this is the last page. So hopefully we kind of know what we're doing by now. We're talking about increasing, decreasing, concave up, concave down, first derivative test, second derivative test, extreme value theorem, candidates test, I don't know, over and under estimates, points of inflection, concavity I maybe mentioned, I don't know, all that stuff. So let's see if we can do this. So it's a good idea to become amazing at sketching functions. That is no joke, given the graphs of their first derivatives. In particular, their first derivatives. Take some practice. So this says I'm going to share 2 techniques that you might find useful. I don't know what those are. So let's see if we can do it. Graph below shows the first derivative f prime of a function. Use the lines below to create stacked number lines. Yes. Use combinations of behaviors, sketch little figures. Okay, all right. I think we can do it. Finally sketch a possible graph. All of that sounds good. So this is the graph of f prime. Got to keep that in mind. This is f prime of x. Okay, so what's going to go on? So we get f prime is going to have a sign chart. F double prime is going to have a sign chart. Things that are going to go on the sign chart for f prime are the places where f prime is equal to 0 or undefined. So here, 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 and I don't think anything else because it's defined everywhere. So let's just kind of translate those down. 0, 3, and 7. All right, so far so good. F double prime. Now f double prime, we know we'll have a sign change anytime the first derivative changes from increasing, decreasing, or decreasing to increasing. So just kind of follow along. You're like, oh, right here, we're going to go from increasing, decreasing. So at -3. And then keep following. So you're decreasing. Something weird happens here, but the derivative doesn't change from decreasing to increasing. It just changes from decreasing one way to decreasing a different way. So that is a place where f double prime is going to be undefined. So I'm going to put it on the sign chart, but you're not going to get a sign change there. So it's one of those, like, we don't really need to worry about it, but we should put it on the sign chart anyway. It's not going to be a sign change. Here, okay, the derivative goes from decreasing to increasing, which means the second derivative goes from negative to positive. So that should definitely go on there. And then here is where the derivative goes increasing to decreasing. So we'll have a sign change in the second derivative. Okay, and now we want to fill in our signs. So the first thing that we're doing, how am I going to color this in? I'm gonna highlight along the x-axis, I guess, for positives and negatives. So f prime is negative from here to here, f prime is negative from here to here, and then f prime is negative here to here, and then positive on this interval and this interval. All right, so negatives. I guess I should also just start this at -7 because that happens, and then end at 8. Close interval. So what are we doing? We're doing negative, and then positive, and then negative, and then positive. So this is all about relation to the horizontal axis. It's above or below, and that. Okay, so then these are your positives, because f prime is positive, it's greater than 0 on that interval. And then these are your negatives, because f prime is negative below the horizontal. All right, and then concave up. So concave up when f prime is increasing. So f prime is increasing here. Let's use a different color. What color? Okay, f prime is increasing here, which means f double prime is positive. F prime is increasing here, which means f double prime is positive. So positive. This is why you want to do a lot of pluses and minuses. So you can see, like, on each little subinterval, you know, is f prime positive or negative? Is f double prime positive or negative? What's the combination mean? Like, that's why we're doing so many plus symbols and minus symbols. Pluses and minuses. All right, and then decreasing, and then weirdness, and then decreasing again, and then decreasing, nothing weird. I wish I would smooth out my, like, crazy highlighting, but it does not. Okay, so f prime is decreasing, so f double prime is negative, negative, negative. And let's this, this, and this. Okay. So now what I do is I look at these stacked sign charts and I just think like, what does the combination of these tell me? Also, going back to where I was like, I'm gonna show you 2 ways to do this. I don't know what I'm talking about. Like, what is the second technique? This is the way I always do this. So what could be the second technique? I'm not really sure. Stack sign charts is the way to go. Okay, so let's see. All right, I know that F is gonna be decreasing and concave up. So decreasing concave up looks like, so it looks, concave up is like x squared, right? And x squared has 2 parts. X squared has a decreasing concave up. So this is F prime is less than 0, F double prime is greater than 0. That's decreasing concave up. And then increasing concave up, F prime is greater than 0, F double prime is greater than 0. And then we have negative x squared. So negative x squared is increasing concave down. So F prime is greater than 0, F double prime is less than 0. And then decreasing concave down, F prime is less than 0, F double prime is less than 0. So always go back to thinking about x squared and negative x squared when you're trying to like piece these things together. And then it's just kind of like flexible Legos or something. So decreasing concave up is going to be decreasing but concave up. It looks kind of like that. So I'm going to say the curve looks something like this. And then at -5, we're going to transition to something else. It's going to be increasing concave up. So that's like the other part of x squared. Then increasing concave down. Then decreasing concave down. Then decreasing concave up. And increasing concave up. Increasing concave down. And decreasing concave down. So now my job is to take these little puzzle pieces and just fit them together so that we get kind of a reasonable thing. I know where some things should happen though. So for example, I know at -5, there should be like a minimum. So I'm gonna put that like here. Then I know at -3, there's actually a point of inflection. I will say I'm not worried at all about y values when I do this. Later on in the year, you'll be a little more worried about it, but like it's a little harder to work out like what y values should be. So just kind of, just do some stuff. Do whatever you want. Like this doesn't need to be a lattice point. Let's do this. So don't worry about that too much is what I'm basically saying. Then we need to decrease. So let's say we get to here. Then at 3, there's a minimum. Let's say that's here for some reason. Then we're going to get a point of inflection at 5. So I'm going to put that maybe here. There's going to be a maximum at 7. Let's put it there for some reason. And then nothing special happens at 8, but it ends. And also nothing special happens at -7, but it starts. All right, so now let's just fill in. So decreasing concave up. Increasing concave up. Increasing concave down. Decreasing concave down. Decreasing concave up. Increasing concave up. Increasing concave down. Decreasing concave down. There you go. That's my graph. This is my possible graph of f of x. I paid no attention, so let's say with no regard for accurate y values. So I didn't try to get those right. I just tried to get the shape right, which is all I'm really asking of you at this point. Soon we will care about the shape a little bit more. We'll care a little bit more about the y values, but right now it's all about the shape. So I think that's it. This is a super good technique. Use it all the time. Get to the point where you can read the graph of the derivative like crazy, and that'll just be a skill that you carry with you all the way. And it comes up all the time. So I'm gonna end this here. I will see you in the next video where I think we're starting maybe the next set of notes. Next set of notes I think don't actually exist. So I don't know what we're doing about that. But anyway, I will see you in the next video. So see you there. And stop.